Welcome you all. Hello, I am Devanjan. Today we are going to define special theory of relativity in a quick succession of time. First, we have to know what is Lorentz transformation equations are. These are four Lorentz transformation equations that relate prime coordinates and non-prime coordinates. Prime coordinates are given with respect to S prime frame and non-prime coordinates are given with respect to the S frame. Here, S prime frame is moving with velocity v along the x-axis. You can see here the coordinates with respect to two different types of inertial frames, S and S prime. There are inverse Lorentz transform equations also exist. X equal to x dash plus vt dash divided by root over 1 minus v square by c square and some others. Next we have to know what is the concept of proper frame. The proper frame where the object remains at rest with respect to the frame. Next we have to know the length contraction formula. L equal to L naught root over 1 minus v square by c square. What is L here? L is the apparent length, L naught is the proper length. What is proper length? Proper length is the length measured in its proper frame. Next we have to revise the time dilation formula. Del t dash equal to del t naught whole divided by root over 1 minus v square by c square. What is del t naught? Del t naught is the proper time, del t prime is the apparent time. Proper time, similar concept, it is measured in the proper frame of that object. Next we have to revise the mass variation formula. M equal to m naught root over 1 minus v square by c square. What is m naught? Rest mass. Kinetic energy expression and the momentum expression. We just have to replace the m by its mass variation formula as mentioned here. The famous equation of Einstein and the momentum energy relation. You will need this for 15 formulas to solve the numericals. Next I will proceed to the numericals. We'll here try to learn three different types of numericals. First one, let me read it first. How fast should a rocket travel so that its length appear to be 50% of its actual length to an observer on ground? As we know, actual length is referred as the proper length. So here the apparent length will be 50% of its proper length. So we can write it like this: L equal to L naught by 2, put it here, and we can easily get the velocity of the S prime frame, or here I can say the velocity of the rocket, root 3 by 2 c. Another problem for you to get used to time dilation. A particle with the proper life mentioned here. Let's see, 5 microsecond moves in the laboratory frame with the speed mentioned here. We are asked to find its lifetime measured in the laboratory frame. First, we have to recognize the formula clearly. We have to apply here the time dilation formula. As I mentioned before, del T naught is the proper lifetime. Proper lifetime is here given 5 microsecond. We have to put it here, and easily we can get the apparent lifetime, and this apparent lifetime is measured in the laboratory frame. Next we have to see another example which is based on the mass variation. Let me read the question. When the mass of an electron becomes 15.16 into 10 to the power minus 31 kg, velocity is n times c. What is the value of n? So we have to first put the mass variation formula. M naught, as we all know, the rest mass of the electron, 9.8 into 10 to the power minus 31 kg, root over 1 minus n square. How we can get it? Just put v equal to nc here in the formula. You can easily arrive here. Next, on equating both sides, we can easily find the numerical value of n, which is 4.5. So you can easily see how important these formulas. You have to remember these formulas for various competition exams also. If you have any doubts regarding these formulas, or you are not understanding the meaning of the variables, you can ask. And thank you for listening to this video. All the very best.